Welcome to the lecture series on vitamins and nutrition. Today, as a continuation from the previous session, we are going to look into the classification of vitamins, which we have already seen, the overall classification. So today we are going to go into the details of individual vitamins. Today we are going to look at the different kinds of vitamins which can be categorized based on their physicochemical properties. And I have been telling you in the previous session that vitamins can be categorized fundamentally based on one particular property, their solubility, what we call it like water soluble and fat soluble. Now today we are going to look into the overall structural features of these vitamins, and we are going to further go into the details of how this physical chemical property of vitamins would play a role in their process of absorption, distribution, metabolism and utilization. So today we are going to look into certain fine concepts of vitamins. So this particular property is very essential for the understanding of vitamins, especially during food processing, where these vitamins need to be added as supplements in the overall process of developing fortified foods. Now if you look at it, this particular slide gives you an overview of variety of the structures that you see over there under vitamins. See, it's interesting to note vitamins have a quite wide variety of structures. Generally, when we categorize organic molecules, especially organic molecules from natural sources, you might be interested to look into the various structures. See, for example, we categorize different natural compounds based on similarity in the structures. So we consider alkaloids, we consider compounds which belong to catecholamine depending on one particular structure. But if you look at vitamins, you would be happy to know that it's not of one particular type but a variety. So each vitamin for that sake belongs to one individual chemical class. See, for example, vitamin A, they belong to retinol group of compounds, whereas if you look at vitamin B12, quite complex, and they belong to porphyrin rings. Okay, and if you say vitamin C, it resembles more or less like a kind of a carbohydrate residue. Okay, and here you have certain vitamins, for example the vitamin K, they belong to quinolone families. So only one thing which basically unites all these vitamins is based on the function that they perform. Individually each one is unique in their own right depending on the chemical structure that they belong to, but functionally there is a lot of overlap. In fact, the common thing that unites all these vitamins together is their role in metabolism. And as I have been telling in the previous sessions, that this property of fat soluble and being water soluble is one of the most fundamental property that decides the way in which these vitamins can get into our system. So I would be repeating this quite often. The reason is, whenever I repeat this, it's not a repetition of the information what I'm saying, but I'm trying to connect new ideas with the previous concept of this property of solubility. Now if you look at this picture, this is a picture which is quite interesting. You see over there we have made a connection between different body organs with a kind of function that they are going to perform. So this would be overall, I would say, a profile, and each of the organ, as you see over there with the numbers mentioned over here and the corresponding function that they play, are quite different. I mean, there is a wide variety of function that you can associate with. See, for example, let me say at random, because we are going to look at these individual vitamins in detail in the coming sessions, so I'm not going to spend much time right now explaining individual vitamins, but I have this slide over here to make you understand how vitamins influence the bodily functions, the physiology of human system in a wide variety of way. Say, for example, if you consider vitamin B12, as I have been telling you earlier, their role is for nerve activity, neurotransmitter. So that's one of the reason for any degenerative conditions vitamin B12 is essential. And for all people who suffer from diabetes, they always give a supplement of vitamin B12. So this kind of tingling sensations what these patients complain, it's because of the degenerative changes that happens in the nerves, and vitamin B12 supplement would really improve the case. And for people who suffer from neurodegenerative diseases, taking vitamin B12 supplement is mandatory. In addition to that, vitamin B12 is also useful in establishing the maturation of RBCs in different stages along with folic acid, what we have seen earlier in the previous session. Now, as you look over here, each vitamin is essential for one function, but as I have been telling you earlier, all are related with each other. So if one vitamin is deprived, then the physiology gets affected, and this is like a kind of a cumulative effect, and this affects every other organ in the body. So now we are going back what I have been telling you. So this water soluble vitamins, to be precise, we have around 9 in number, and the fat soluble are 4 in number. So today I am going to dwell more on this particular concept called bioavailability. Okay, so you look at bioavailability of vitamins. So before we go on in relating this concept of bioavailability with vitamins, first of all we need to know what exactly bioavailability means. See, the very word bioavailability consists of two different concepts. So bio refers to living organisms, and availability, it means how much of the particular ingredient is available for human system to utilize it. So this concept of bioavailability is extremely essential when we study about drugs. See, for example, we might take different substances through oral route. The substance can also go into our system to through systemic circulation by the way of injection or parenteral route. But bioavailability is a very important concept, especially concerned with the orally taken substances, because bioavailability refers to how much amount of the substance is essentially available for systemic circulation. Say, for example, if you look at bioavailability, let's say you are taking 100 mg of a particular substance. Let's say you are taking 100 mg of vitamin A. Now this 100 mg vitamin A should go into systemic circulation. So the best way is directly inject vitamin A into the system, and 100 mg is directly available for the body to utilize. But that's not the case when it happens when we take a medicine through oral route. See, for example, in the oral route is basically what we call it like the alimentary canal. Starting from the mouth till the point of anus, it's considered as the alimentary canal. Okay, so it's actually an extended tube with variety of organelles, functions, and variations in the kind of absorption could be observed throughout the alimentary canal. Okay, so what exactly is bioavailability? So we take bioavailability of a substance which is being directly delivered into systemic circulation as the ideal. So you say bioavailability of any substance taken through parenteral route, especially taken through intravenous route, is 100%, because there is no loss of the substance what you are taking and the amount that could reach systemic circulation. But suppose if you are going to consider bioavailability where you ingest something and it doesn't completely go into systemic circulation. So that's why we have to really look into this concept of bioavailability. Why? Because all the substances whatever we take, because vitamins, as I told you earlier, until otherwise we are going to take separate vitamin supplements, most of the vitamins what we need on a daily basis, basically we derive it from food. So you have to consider in the whole quantum of food that we are considering, the substances what we take will have carbohydrate, will have protein, will have fat, and among them your vitamins are also present. So the vitamin has to basically get into your system from this major nutrients or macronutrients and finally find its way into the system. So you look at this picture, it's a very interesting picture. So you see here in the oral cavity, starting from here, the food gets digested, there is mechanical breaking down of food, and till the point you reach stomach, where apart from mechanical breaking down, the mechanical breaking down also continues there because of the musculature of the stomach, but more often here you have the digestive enzymes and the environment, which is acidic in nature, would break down chemically the substances, and as they go down, you find in the small intestine you have other organs, basically pancreas and secretions coming from the gallbladder, which is basically the bile processed by the liver and gets mixed up with the food substances, and finally the absorption happens in the small intestine and then it goes into the large intestine. So you see there is mechanical breaking down, then there is chemical digestion, and finally what you call as absorption of the material. So in this, the amount of substance, let's take the same example. Suppose we have to take 100 mg. 100 mg is too much. Let's say a limited quantity of vitamin A. So this vitamin A present in the food, when you are consuming the food, how much amount of vitamin A finally made it to systemic circulation, and that's the most important concept that we need to consider. Okay, so accordingly bioavailability can be defined as, in terms of food material, is applied to food-borne vitamins in human nutrition, refers to the proportion of the quantity of vitamin ingested and undergoes intestinal absorption and utilization by the body. So when we say utilization, means it's getting really into your system, it's been utilized by cells, it's been utilized by tissues. Okay, ultimately the fate of the vitamin. See, always remember, anything that we take, the macronutrients or micronutrients, would be finally broken down and would be utilized by our system, and once the job is done, it would be metabolized and eliminated. So of all the organs in our body, almost there are many organs which are involved in metabolism. So what is metabolism? Metabolism is breaking down of these substances chemically, so that your body would find it much convenient to utilize the substance, and at the same time the body, if it finds any of these substances which are being broken down are not going to really help us, or rather going to be a toxin in our body, will be eliminated in a systematic manner. Okay, so you see there in bioavailability you have to remember the key word, proportion of the quantity of vitamin ingested to the amount that really goes into systemic circulation. So as I told you, let's say 50 milligrams of vitamin A you are taking, and if all 50 milligrams is available by your system in systemic circulation for the site of action, then your bioavailability is 100%. But suppose if only, let's say, 40% of the substances go into systemic circulation, your bioavailability has now cut down into half. So now why this happens? And this is particularly a feature we need to consider when you take anything through oral route. Okay, because in oral route we have a concept called first pass metabolism. Okay, so what is first pass metabolism? So you need to be aware of this particular concept called first pass metabolism. But before, I'll just put a hold on this particular concept called first pass metabolism. I'll just give you overview of exactly what the digestion happens, the overall process of digestion. Then we will go back to the first pass metabolism and then explain the role of first pass metabolism in diminishing the amount of substances, especially vitamins, reaching systemic circulation. So you look at this picture, this is a picture, and this picture is exclusively explaining the way how lipids are digested and absorbed in the small intestines. Now a word of caution that we need to consider. You know very well the macronutrients, fundamentally the energy giving carbohydrates or the energy storing substances, basically the lipids and fats, and also the proteins, which are the building blocks of enzymes. So each of them are chemically different. See, carbohydrates is basically a polyhydroxy compound, which is basically a polyhydroxy compound with the aldehyde or a keto functionality present over there. Whereas if you consider amino acids, it's basically a polymer of I would say the protein is basically a polymer of amino acids, and whereas if you consider lipids, they are basically esters of glycerol and fatty acids, long chain fatty acids. Okay, so now we are not going to go into the details of biochemistry, but I am reminding you why this is important. So in this picture you have how a lipase, being an enzyme, breaks down the lipids. So the lipid, being a macromolecule, needs to be broken down, because it's an ester, needs to be broken down into fatty acids and glycerol, and only then it can go into systemic circulation. So why we need to look at lipid absorption as a feature? Because as I told you earlier in the earlier classification, so you look at this picture, in this classification we have fat soluble vitamins. So if you say fat soluble vitamins, all the lipid that is present in our diet would now find it much easy for this fat soluble vitamin to go along with that. So similarly, those substances which are water soluble would find its way through hydrophilic substances in our diet. So that's one of the reason, if you want to like improve your bioavailability for vitamin A or vitamin D, take it along with the diet rich in lipids. That really gives a dividend of increasing the amount of vitamin A or vitamin D that could reach systemic circulation. And if you choose the wrong kind of combination, obviously the bioavailability and the absorption of the food material would be affected. So that's the reason in this picture we need to look carefully our lipid metabolism would happen, and this lipid metabolism is closely associated with fat soluble vitamins. So you look at this, especially the fat would be broken down, it would be, I would say, emulsified, and the bile would do the job of emulsification, and finally the emulsified globule. So what is basically emulsified? You see over there, this picture, you have tiny droplets. So the big globules of fats are being broken down into tiny droplets, and these droplets are being emulsified by the bile, and then exactly there is this particular enzyme, what we call it like lipases. Okay, so these lipases take care of breaking down the tiny globules, because the moment you break down into tiny globules, you increase the surface area for lipase to act upon them, and the lipases which are being produced by the liver and basically in the small intestines break down and make the glycerol and fatty acids available. And here you have the villi. So villi, you have this brush border villi, and between the villi you have this particular structure called lacteals, which provide the basis for the absorption of fatty acid and glycerol. So now a fat soluble vitamin like A, D, E, K can go very well along with these globules, okay, the tiny globules, and through their metabolism could reach systemic circulation. So you get it? So every time any lipid molecule in a diet would be there, and if vitamin which are fat soluble are available, basically gets dissolved along with them and find their way inside systemic circulation. So same is the case for hydrophilic substances. Okay, so now coming back to look at one more definition, the definition given by the National Institute of Health's Office of Dietary Supplements. So there are many technical definitions available, but in all definitions the meaning is the same. So I have just picked out this particular definition so that in a different shade of meaning you would be able to appreciate what exactly this bioavailability is all about. So you see here, it's the amount of substances absorbed in the intestines and ultimately available for biological activity in your cells. Okay, so now what is a good bioavailability? Good bioavailability will be always, let's say, 100%, but that's not the case for all the substances taken through oral route. So a bioavailability of more than 80% is considered good. So why we need to be worried about bioavailability? Because if bioavailability is going to be very poor for a particular vitamin, then extra precaution needs to be taken to supplement for the loss in the amount of substance what we are consuming in a particular time. So that's the reason we need to be really looking into what factors that really decide bioavailability. So in this particular point, as you see over here, the fat soluble vitamins are absorbed in the same manner as lipids. I have been telling you right all the way, and you see over there water soluble vitamins don't have this barrier and they readily get absorbed into the bloodstream, whereas this fat soluble vitamins have to have some kind of a lipid related vehicle present in our food. Through their route would reach systemic circulation. Okay, so you see that what is that key physical property, because in your syllabus we have to look into the physicochemical properties. So of all the physicochemical properties, the consistency and the chemical nature of it and the way how they behave to different solvents, so this component of solubility is extremely essential for vitamins. In fact, for all fat soluble vitamins there are different preparations or formulations available to improve bioavailability. Rather than giving it like a simple fat soluble concoction, if you could emulsify them, the chances of bioavailability can be drastically increased. So you see over there what I have been telling you all along, the flow of bioavailability is basically digestion, absorption, transportation, storage and excretion. So the digestion and absorption is extremely essential in terms of bioavailability. Transportation and storage play an important role in distribution, and finally the substance is being excreted. When it's being broken down, utilized by our body, they would be ultimately excreted. So you see there you can have a comparison of water soluble and fat soluble. So most of the fat soluble vitamins, if you consider, can be or should be delivered in the form of a soft gel capsule kind of a formulation, and if it's a water soluble, you can go for any kind of a compressed hydrophilic substances in the form of tablets, and the bioavailability is like really works well. Okay, now we move on. Before we move on with bioavailability, I want you to be aware of this particular concept called first pass metabolism. So what is first pass metabolism? So you want to know that how this particular metabolism, which is the ultimate metabolism of breaking down any material in our body. Always remember, when we use the word metabolism, we are talking about how we are breaking complex substances and releasing simpler ones, and using these simpler ones as building blocks, we try to build our own body, our own tissues. So this is actually the process of metabolism. So in any metabolism you have two aspects, what we call it like catabolism, which is breaking down, and anabolism is building up. Okay, so every food material what we consume will undergo this process. It will be broken down as catabolism would allow it, and the raw materials released in catabolism would now be picked up and would be used in the process of anabolism to construct a body structures. I would say all the tissues and every other elemental composition that we have in our body. Now if you look at it, so if you could narrow down what are those key organs that are involved in this major step of metabolism. So you should always remember, liver takes up one of the fundamental functions pertaining to metabolism. See, the metabolism of liver happens in such a way. In fact, you know, every organ in our body, especially after absorption, is routed through liver. So what do you mean by that? So there is this systemic circulation. The blood basically would go very close with the small intestines. So as the food material basically gets broken down, directly the blood vessels which pick them up would be able to utilize this particular nutrients, and then it goes into systemic circulation. So that's how we actually consider our water soluble vitamins reach systemic circulation. And you have to be aware, there is a separate set of, I would say, transportation between liver and all the other organs connected with the alimentary canal. So this is what we call it like portal circulation. So what is this portal circulation? See, when a substance is getting absorbed and it will go to the site of action, probably tissues or cells where it is needed in a metabolic process, and then when the job is done, the byproducts or the metabolites released as part of the chemical reaction would now find its way into systemic circulation. So this is how it works. Now what happens in first pass metabolism? Before it could reach systemic circulation, some portion, depending on the kind of food material, would now go to liver before ever it could even go for systemic circulation. So this is what we mean by first pass. A portion of it passes through. It's not the entire amount going into systemic circulation, but a portion of it goes into systemic circulation. So this first pass metabolism going to liver, obviously you know liver is the site of metabolism. The moment it goes to liver and the enzymes in the liver are going to break them down. So the moment they are being broken down into small pieces, the total bulk of the vitamin, what was earlier anticipated to go into systemic circulation and finally find its way for the kind of metabolic role that they have to play, would now be cut down. So that's what we need to consider. So in first pass metabolism, what happens? The amount that goes into systemic circulation before ever it could reach the systemic circulation would now go to the liver, and the liver would cut down, would break it down, and then the metabolites are released into systemic circulation. So this is a major problem, and this is a problem that's there for every substances that are being taken through oral route. So in fact, in pharmaceutical industry, bioavailability especially becomes a huge problem for those substances where first pass metabolism happens in the liver in a considerable amount. Okay, so you look at over here, sometimes this first pass metabolism can be beneficial. Okay, you might be wondering how it is beneficial, because we are just talking about amount of substance, at least half of it goes to liver and gets destroyed, and it's not available for systemic circulation. But you see over there, there are some substances, what we call it as provitamins. So what are provitamins? Provitamins are kind of a precursors. So in the natural realm, from the food substances, whatever we take, see during digestion, digestion is also a kind of a degrading process. So although we consider digestion to be extremely efficient, breaking down complex material into small ones, but some of these enzymes are too tricky to handle, and in the process of breaking down, they sometimes completely chop down the substances and make it completely inactive for absorptions. So we have an alternate approach, and these substances are in nature available as provitamins or pro substances, or what we call it like precursor material. So precursor material will be inert, and it will undergo the routine process of absorption and pass through the enzymes, and enzymes will not be in a position to break them down, and finally when it goes to the site of metabolism, the provitamins would be converted into active vitamins, and then it will be available for systemic circulation. In fact, this approach is being effectively utilized to surpass or overcome this problem of first pass metabolism. But this very first pass metabolism, if can be utilized for our advantage in making the vitamins available for circulation, can also be done by converting them in the form of a provitamin and then making it available for circulation. But sometimes provitamin related foods do this in a natural way. So you look at this example. For example, this one, beta carotene, which is abundant in the colored vegetables like carrots, and this beta vitamin is the precursor for vitamin A. So either you consume vitamin A as such, or whether you consume beta carotene, both mean the same, because even if you are going to take it as beta carotene, your body is going to convert beta carotene into vitamin A. That's something very interesting. So you see, it's converted to an active form once it is absorbed. Now my question is, so you may ask whether the provitamins are getting converted into the active form only in the liver, or it's been acted upon by other substances. The answer is both ways. Yeah, some of them, as they pass through first pass metabolism, liver would do the active job of converting these inactive substances into active ones. On the other hand, some of the substances would undergo the routine pathway of absorption, and inside specific organs and structures, even in the brush border regions of the intestine, and even after being available near the tissues, and the corresponding mechanism of converting them from an inactive form to an active form would be in play. So you see, so vitamins are preserved that way. So you could improve bioavailability by making these substances available in the suitable form so that there won't be any loss. So I think we are going to come to the end of this session, and I'm just going to do a quick recap of bioavailability. As I've told you earlier, that bioavailability is an extremely important concept to understand the process of how vitamins are digested, absorbed and made available for systemic circulation. So in fact, we started this session with a little bit on what exactly we are going to look at as the vitamins associated with body functions. So I gave you an overview of how every vitamin is connected with every physiological function. So this was a picture that gives you an overall feel as how vitamins are so essential. And I also briefed on, although vitamins can be grouped together because of their role in metabolism, on a closer view you find each of the vitamin is so unique, each of them are so unique chemically, you can't actually categorize all of them into one particular class. The only way you could categorize them is through connecting them based on the function. So we also saw about the concept of bioavailability. So I think we'll wind up with this session, and we'll continue with the concept of bioavailability in the coming sessions. Thank you.